Welcome to a video on exponent challenges. So we're assuming that you have mastered exponents, the basic idea of exponents, and you're ready for the next step. So some of these uses are things that you're going to see more in 7th, so we're going to give you a head start. Here we go. Today students will be able to expand their ability to solve problems with exponents by learning new exponent rules and patterns. All right, the first thing we're going to look at is exponents with powers of 10. I want you to take a look at this chart and see if you can notice some patterns. 10 to the 4th power, let me turn that volume up. 10 to the 4th power, we know, is going to be 10 times 10 times 10 times 10. Well, when I multiply 10 times 10, I really kind of add those two zeros, so we know that that's 100. And then when you do 100 times 10, you know from experience that you're going to add another 0, and another one, another 0. So let's see if we can figure out kind of a pattern. 10 to the 4th power, we can see becomes 10,000. 10 to the 3rd power is 10 times 10 times 10, which is 1,000. 10 to the 2nd power is 10 times 10, which is 100. 10 to the 1st power is just 10. So I want you to look over here and see if you notice how could we get from here to here really quick and easy by just noticing a pattern. Well, if you said, hey, I noticed that when it's to the power of 4, there are 4 zeros. When it's to the power of 3, the answer has 3 zeros. When it's 10 to the power of 2, there are 2 zeros. Power of 1, there's 1 0. So that is a really nifty pattern. So really quickly, I can take 10 to any power and know the answer without a calculator, without working it out, by just putting that many zeros. And you can test that out with a calculator just to make sure that that pattern is true. Let's keep it going because we're going to look today at negative exponents. 10 to the power of 0, we know is just equal to 1 because it's a 1 with 0 zeros. Now, what if we go the other way? 10 to the negative 1. If I do that on a calculator, you're going to get a decimal of 0.1. Well, another way to say this decimal is 1/10. So here's the rule with negative exponents. We want our exponents to be positive. If it's negative, then we need to take the opposite of 10 to the negative first, because the opposite of a negative exponent is a positive. Well, we can't just do the opposite of this and leave this the same, because that's going to change our value. We could kind of think of the opposite of 10 as 1/10. So 10 to the negative first power, you're going to just put a 1 and make this into a decimal. And then when you invert this down to the bottom, this negative is going to become a positive. So that's going to become 1 over 10 to the first power. Let's keep going. So 10 to the negative 2, we're going to put the 10 on the bottom so that this can be positive. So it's going to be 1 over 10 to the 2nd power. 10 to the negative 3, you're just going to put the 10 under the fraction, and instead of being to the negative 3, it's now going to be to the positive 3. 10 to the negative 4th, we're just going to put the 1 underneath the fraction, or the 10, I'm sorry, underneath the fraction. And now instead of to the negative 4th, it's to the positive 4th. So when I'm solving this, 1 over 10 to the 2nd power, what that's going to look like is the 1 is going to remain the same, and then we're just going to solve 10 to the 2nd power on the bottom. So 10 times 10, which is of course 100, and this is another way to say 1/100th is 0.01. Over here, 1 over 10 times 10 times 10, which is 1 over 1,000, and sure enough, this is 1/1000th. 10 to the negative 4, we have 1 over 10 to the 4th power, and we're just going to do that 10 times 10 times 10 times 10, 10 to the 4th power, add 4 zeros, 1 to the 10,000ths, and sure enough, this decimal is 1/10,000ths. All right, let's move on. All right, so this is just a practice sheet that you have to practice powers of 10. I'd like you to try to remember the pattern or the trick. So go ahead and work on that. And when you're ready, you can unpause to look at the answers. So please pause your video, give it a try, and then check your work. All right, so here are the answers that you should have gotten. See if you're right. If you made a mistake, just go ahead and fix it before you move on. All right, now what I want you to practice is also take exponents just a step further. All you have to do here is you might have to solve in 2 steps. So if you get a problem where you're multiplying numbers and more than one number, all you're going to do is find the value of the exponent and multiply your numbers. So for this, we're going to use order of operations. We're going to do the second. So 83 times 6 second power. I'm just going to write the value of that underneath. And I'm going to solve 83 times 36 and write my answer here. For this problem, 1 to the third power equals 1 times 8 to the second power. 8 times 8 is 64. Now I'll multiply and solve. 5 to the second power is 25. 3 to the power of 0, remember, is always 1. And then I'd multiply and solve. So go ahead and give that a try. Again, pause your video, give it a try, and unpause to check your answers. All right, go ahead and take a look. If you made a mistake, circle the one you made a mistake on, pause the video, and try to fix it and figure out where you went wrong until your answer matches mine. All right, let's look again a little bit more at negative exponents. So you saw that it worked with the powers of 10. And now let's go ahead and solve this. Then you're going to practice all of these things on IXL to get a little bit more work with it. So 5 to the power of 3, I don't want a negative 3. I want the opposite, or in math, call that the inverse. So instead, I want 5 to the power of 3 positive. But if I'm going to do the opposite of this, I have to do the opposite. So the opposite of 5 is going to be 1/5, or the inverse. So 5 to the negative third is going to be 1 over 5 to the positive third. This one, 4 to the negative second power. I really want 4 to the second power. I want this to be positive. So instead of 4, that's come 1 over 4. Try this on your own. Think about in your head what you think it's going to be, and then I'll let you know if you're right. All right, you said 1 over 3 to the positive. You are correct. If I wanted all of these and bring them to standard form, I could do that. I would leave the 1 on top, and it would be 1 over 5 to the third power. So it would be 1 over 25. Here, 1 stay on the top, but it would be over 4 times 4. So it become 1/16. 1 over the 3, there's 1. 3 times 3 is 9 times is 27. Times 3 one more time is 81. So there you go. All right, one more thing I want to show you before you start practicing IXL, and that's square roots. You might not have seen these before. All right, so we know that 5 to the second power equals 5 times 5, which equals 25. A square root really just does the opposite. So if I put 25 in, this is called a square root symbol. This means, what is the square root of 25? What they want to know is, what number to the power of 2, what number squared equals 25? Okay, so what number squared, what number times itself equals 25? So if I was going to figure that out, I would say the square root of 25 equals 5, because 5 to the power of 2 is equal to 25. So let's try another one. How about the square root of, let's see, how about 81? So the question is, what number to the power of 2 is equal to 81? Well, if I think about it, I know that 9 to the power of 2 equals 81. So if I'm given this problem, what is the square root of 81? I'm going to say that equals 9 because 9 squared is 81. Let's try another one. How about the square root of 36? And what you want to know is what number to the second power equals 36? What is x? Well, I know 6. Second power, 6 times 6 is 36. So the square root of 36 equals 6. One more. How about the square root of 100? What number to the power of 2 or what number squared equals 100? Well, 10 to the power of 2 equals 100. So the square root of 100 equals 10. All right, that concludes your challenge video. You're going to go to the web page, Chapter 1, and the extensions section, and go ahead and practice some of these ideas on IXL. Good luck.